Hi, everyone. Welcome to another episode of Cloud Masters. I'm Matan Bordeaux, your host, joined by my co-host, Sam Clark. We're joined by two additional doers, Avi Keinan and Javier Carrera. They are both senior cloud architects or senior solutions architects, depending how you view it. Same thing to us, though. At DoiT, they help customers with tons of AWS issues, not just restricted to AWS, but they're here to talk to us about an upcoming price hike announced by AWS back in July that's set to take into effect in February 2024. Specifically, they're hiking the prices of IPv4 IP addresses. Is that how you say it? Maybe Javier, you can start us off by just describing in more detail what's happening. I understand this is not as nefarious or evil of a price hike as it may first appear. They're trying, I think it's AWS trying to guide guide customers to better behavior. Is that correct?
That's right. So this change was announced back in July, and it's bringing AWS in line with Google Cloud and Azure, who are already charging customers for using public IP addresses. So this is no big surprise. It's just something that I think would happen sometime. And the date will be February the 1st, 2024. So basically, as I said, AWS is going to charge for public IP addresses, something they didn't do before, with the exception of the elastic IP addresses, which had a charge if you were not actually using them after requesting them. And also, they charged you for using secondary public IP addresses based on elastic IP addresses. So this is a change that will affect most customers in one form or another. They are using public IP addresses. Avi, is there anything you would like to add to this announcement? I think it's relatively clear, right?
Yeah, Avi, maybe you describe actually why are they doing this?
Basically, AWS, they already have something like 136 million IP addresses. So they have a lot. And the problem is that every time they onboard new customers, they need more IPs. And it became, let's call it a struggle to find enough IP addresses in the open market because you can't get more IPs from the providers anymore. So it feels like they try to set the minimal price that they can to make sure people will try to avoid using that. So we will charge the minimum, and we hope that the customers will start using the best practices, all the other options that are available to make sure that people won't use IPs just because it's free.
So our IP address is kind of like it's a finite resource, at least for I guess in general, but IPv4, it's kind of like Bitcoin, where there's a set amount, and I guess the more that people mine, or in this case, the more IP addresses that are assigned, the more expensive that the leftovers become. And it's been costing more money that way.
You can, in theory, you can use up to 4.29 billion IPv4 addresses, whereas there are like 340 trillion IP addresses in version 6 of the IP protocol, right? So we can be sure that we are not going to run out of IPv6 IP addresses. But that's a story we'll tell later, right?
Yeah, I'm actually looking at a chart right now, Avi, that you shared in a blog post about this. And it looks like from 2010 to 2020, the range of per IP, cost per IP was like $10 to $20. And now it's somewhere between $30 to $60 over the last like 3 years. So yeah. I guess makes sense.
It depends on the size, the location. Think of that. Let's say I want to buy, the minimum that you can purchase is 256 IPs. For AWS, purchasing such amount of IPs, it's a waste of time. They need people to sell them like millions and millions of IPs. And other than that, think of that like you need to expense $4 report. The time it will take you to process the report inside the company will cost more than the amount. By the way, I think like 30 years ago, to promote the internet, companies like Visa, Apple, Disney, they got like, they were assigned like millions or tens of millions of IP addresses. So let's say you have Apple that wants to buy IP addresses, or Amazon that wants to buy IP addresses, and they can buy it from Apple, which they are considered as competitors, or they can buy it from Disney, who are also competitors. So your only option to purchase huge blocks of IP addresses is from your competitors. So it's not something that is going to work. It's not something that is easy to AWS to find providers with plenty of IP addresses. I think the last block that they purchased was 3.something.something, and that was from Yale University. So you don't have many options to purchase IP addresses.
We discussed what's happening and why. I think it's about half a cent per IP now they're charging you per month, or
it's
per hour.
$3.65 per month.
$0.005 per IP per hour, which seems like a small amount of money, but once you multiply that by hundreds or thousands of IP addresses, that can sum up to a nice amount. I just wanted to add that this will affect not only EC2 instances that you connect to public subnets, but also to AWS managed services. So this is something to be aware of. For example, if you're using the site-to-site VPN service, managed service, that consumes two public IP addresses, you will be charged for that, in addition to what you have to pay for using that service.
Right? So that leads me actually to a question, Javier. There's one service that pops to mind, and that's load balancers, right? So typically with AWS load balancers, the way they work behind the scenes is if you've got an ALB, let's say, then it's deployed actually in all three AZs where you deploy that. It's got three separate public IP addresses. In DN, you aren't given the IP addresses in the console because they can change as Amazon replaces them, scales them, all that sort of thing. The best practice is to connect via DNS. You use your DNS address, you get back an IP, a public IPv4 address. Am I going to get charged half a cent per hour times 3 for each of those?
That's right. And not only that, because load balancers are auto-scalable, meaning that if you get a lot of traffic, then more nodes will be deployed in each of the subnets. So it's not only 3, but even more, depending on the workload.
It starts at 3, yeah, exactly. That means that I need to switch everything to IPv6, but some clients can't use IPv6, right?
I don't think that's the correct answer. First of all, ALB can have up to 100 IP addresses, if I remember correctly. But if you have 100 IP addresses with one load balancer, it means that your invoice is something like 6 or 7 digits. So the cost of the public IP is not something you are worried about. But you still need to support IPv4. You still need to provide services to your customers. Even if small portion of the world works with IPv6, the majority of your customers are still running IPv4, and you need to support that.
Exactly. So this is, back in the days I worked at AWS, we always used to talk about how we'd never raise prices. And you could argue that this is an introduced new price rather than a raised price. But at the end of the day, this is probably going to have a fairly significant impact on most customers' bills. For a start, when you deploy an EC2 instance, by default, it's in a public IP subnet. And what we mean by public IP subnet for most people is something that has an IP gateway, an internet gateway assigned, and something where by default you have the option enabled to assign a public IP address per instance when you deploy it. So most people in the world are going to have that running. That's even just that little bit is going to add a huge cost to everyone's bill, right?
It's going to affect, I would say, all customers, and the impact will depend on the amount of resources that they are exposing on the internet. We have done some analysis on that impact, and there's no common pattern. Every customer is different. They use services in different ways. They expose their services using different approaches. And we have cases where large customers will add a significant cost to their bills. And there are others where the impact will be minimal. Avi, we have some extreme customers here, right? Because we have some very, very large customers using public IP addresses massively. And also we have some smaller customers whose bill is not that big monthly. But the impact of this change will be significant, right?
So I did a test on my end, and for the average customer, it's 2.6% increase. So if you are average customer, if you're not doing something special, that's probably the impact of your case or even invoice. But we did have two customers where in one case, it was a low increase, but it was $25,000 per month. And for many companies, $25 per month, you can hire 2 more people with this budget. So if they gave you 6 months notice to make sure you will spend the time migrating to a different solution. And another customer, the price was, I think, 2,000 euros, but it was 30% of the invoice. So a price increase of 30% of your invoice, it's significant. It can destroy your business model if you're small business.
I guess in a nutshell is, even if it's not a big portion of your bill, if the change doesn't cause like a big increase in your bill, you should still look at the absolute number, because it could. I mean, there's opportunity costs. What could you do with that money instead of paying for those public IP addresses that now cost you money that didn't in the past? But for the average customer, for any customer, I should say, how can they evaluate the impact? I know AWS gave some tools. I know you can also understand this in the DoiT console, but let's start with AWS.
AWS, on the day they announced this change, they also announced a new free feature associated to the VPC IP address manager service. And this new feature allows you to analyze your consumption of public IP addresses. So you will be able to, using this tool, which is free, see how many public IP addresses you're using and the impact of this price change. I have to add that although this tool is free, it's a regional analysis, meaning that you have to go region by region and account by account to see how many public IP addresses you're consuming in each of the regions per account. There are other alternatives. One which is straightforward is using the CUR, the constant usage reports. So, and this is something we also leverage, and I guess Avi might want to add something here, but the CUR is the default way that AWS reports your consumption. And there are SKUs, IDs that are associated to resources or features that you're consuming. And 2 additional SKUs were added, and they are already present in your report, so customers can analyze it. Those 2 CURs are called a public IPv4 idle address and public IPv4 in-use address. So if you look at your CUR reports, you can know how much you're going to be paying for those resources after February the 1st.
Those addresses, I assume, are regionally keyed as well. So it'll be EU-public IP and AFS-.
That's right. But as you will get a single core report for all your accounts in all your regions, then it's easier to analyze the total consumption.
I think that the easiest way, if you are not scared by the word Cost Explorer, if you're not frightened, that would be the easiest way, because it allows you to see all the regions in the account. And if you are logged into the organization account, you will be able to see the entire organization usage. If you check before February 1st, the cost is zero, because the price announcement price increase starts on February 1st, but you can still see the number of hours that you have in each region. You can multiply it by the price, 0.005, and then you get the cost for that region, for that account. It depends on the way you sort the costs. We published a nice blog post that shows everything, explain it in details. I assume we will add it to the comments of this podcast. And for me, it's, I prefer Cost Explorer rather than logging to each of the accounts, each of the regions. The tool that is available from the IP address management page, it's only available from the console. There's no way to trigger that from the CLI. If you want to digest cost and usage report, good luck. Sometimes it's more than 50 gigabytes of data. So it's not easy, not an easy task, and also not available for everyone. So if you have access to Cost Explorer, this is most likely the easiest way to do that. Even if you are afraid from the name of this product and that too many numbers, too many graphs, we shared a detailed explanation on how to extract the costs. And that's the way I would do it.
And additionally, if you are a DoiT customer, you have the cloud analytics functionality inside the DoiT console, right? And it's, I would say, much easier to consume than the Cost Explorer approach, right?
Yeah, I think we'll probably include a graph, or not a graph, either a graphic over this or a video. It's as part of like the episode notes that just shows how you would calculate this in the DoiT console. And of course, Avi already shows in his blog post how to calculate it in the Cost Explorer via screenshots.
We also reach out to our customers that are going to spend a lot and notify them. So if you look for another reason to be a DoiT customer, here we go.
Yeah. So let's say person listening to this has evaluated the impact, how much it's going to cost them, whether it's 2%, 5%, 1%, and they made the decision, I need to get off of this version 4 stuff. What are their options, and in which case would you go with different options? Feel free to include your opinions, what's best, what's easiest, etc.
Getting rid of IPv4 public IP addresses is not that easy, right? And not all services in AWS support IPv6 fully. There are some limitations. So at least you should try to expose as little as possible using public IPv4 addresses, right? So you can try to avoid using NAT gateways if possible. If you're just using, if you're just simply accessing AWS services, you have the VPC endpoints. Both interface and gateway VPC endpoints allow you to save money when accessing AWS services in the same region. Also, you have the AWS Global Accelerator, which still consumes public IP addresses, but you can expose multiple services through the public Global Accelerator IP addresses. And so in general, try to be as efficient as possible with what you already have at hand, meaning that you don't have to throw away what you already have, but try to be more efficient using those resources in order to minimize the public IP address consumption. And on the other side, we have the strategy of adopting IPv6, right? But this is, again, there's no direct migration in some situations. You need to understand the impact of those changes, whether your application will be accessible to all customers. So you need to study this change, and this is not something you can do from one day to the other, right?
One way that you could go ahead, like if we talk product specifics here, and obviously I'm not going to go into 200 different AWS services, but EC2 is a really common one that almost everyone's using, and a lot of people, through default, through laziness, whatever, use the default VPC with default subnet settings, and so they might deploy an ASG, an auto scaling group. They might deploy that with a standard template, which automatically assigns every instance in that group with a default public IP address. Those are all now going to get charged, and then they're sitting behind a load balancer that is also getting charged for those. So when it comes down to being a little bit more deliberate about your public IP address usage, you want to go and look at things that really don't need a public address, things that could use an internal path, internal to your cloud setup, so that you can get rid of all those public addresses, stop paying for them, and just use the ones that you really have to, for example, on your public-facing load balancers or something like that, right?
So one more thing that I will add, if you know how to evaluate your services and if you know what it's doing, you may be able to remove it completely. Let's say you have a simple app with a web server and a database. The web server can work with private IP. The database can work as well. And your only expense for public IP addresses is for the load balancers. So if you know what you are running, you might be able to cut your costs dramatically.
You go and look at my private accounts, because I'm pretty sure I've never bothered changing the default settings for public IP addresses. It's only going to be $3 a month, but that's $3 I can have instead of Amazon, right?
Yeah.
There are some low-hanging fruits. I'm thinking of bastion hosts. Bastion hosts have been typically used to enable the management of internal instances. We have at least two alternatives to bastion hosts currently in AWS. One of them is Session Manager, and the other is the VPC VPC Instance Connect endpoints, right? So using these two approaches, you can access internal instances without consuming the public IP addresses of the bastion hosts, right? So if you really analyze how your architecture is deployed, you can find opportunities to save some money and additionally increase the security of your configuration, right? So as I said, you don't necessarily have to move to IPv6 to save some money after this change. You can start using functionality that's already in place.
Avi, didn't you mention, I think when I went through your blog post, you also mentioned some open source solution as well, but I'm not sure how applicable it is to listeners. I don't know if there's specific requirements, but maybe you can talk more about that.
There are a few alternatives, just like Javier mentioned, that basically instead of each EC2 instance or each resource in your environment would have a public IP address, you can have a private IP address, and then you can route the traffic outside to the internet with other solutions. That could be like a vendor firewall. Let's say Checkpoint, FortiGate, Cisco, all of the above. They have their own firewall solution. You can also use NAT Gateway, which is a great solution. But if you consume a lot of data, you will pay for the processing fees, which might be higher than the cost of public IP addresses. And there is an open source solution called Alternet, which they have like plenty of stars on GitHub, but I didn't test it. I'm not sure it's a good recommendation for a production VPC, production workload. But the way it works is that basically it routes the traffic through an instance that acts as a NAT. And there is health check with Lambda, I think, that simply makes sure that if this instance is going down, another one will pop up. And you're only paying for the instance. So instead of paying, let's say, $300, $500, $800 per month for vendor firewall instance or NAT gateway, you can simply pay only for one instance.
I've recommended Alternate to a few customers, and they've been really happy with it. I think they've got some calculations on their own webpage. It depends a lot on the size of the instances you use, the traffic that goes through it, so on. But once you start pushing something sort of the 5 to 10 terabytes of data a month kind of range, then it becomes really quite a good cost-saving type methodology. What's also really cool about it is they give you the configurations to turn any regular instance into a NAT gateway or into a NAT device. They give all the commands. It's part of the setup. And also it's backed by actual regular NAT gateways. So there's a fallback plan there that the instances are never unreachable. There's if all of your instances do go down, then it will route the traffic through NAT gateways. But that has the flip side that you're still paying the NAT gateway running costs because they are still present in your environment. So the big cost everyone complains about with NAT gateway is the data processing. It's removing that.
Is there like a rule of thumb, or like if I think about for Spot instances, they say, oh, for your development and staging and testing environments, use Spot. For containerized workloads, use Spot. For CI/CD, use Spot. Is there just buckets of industries where, before, even without calculating the impact, because you're in this type of industry or because this is a specific type of application, you should highly consider checking the impact because you'll probably heavily impact it? Or is it just kind of like some companies in the medical, in healthcare, health tech, they'll have some high costs as a result of this and some others won't? Is this industry specific? Is it or is it more likely are we more likely to see a cost spike or a higher percentage impact of your total bill in specific industries or specific types of applications, or is it just kind of like a wild card?
I think that if you process ingress and egress more than 5 terabytes per month, you should consider using one of the tools that we mentioned. But the problem is how to calculate how much you process. It's not easy. You are not aware of all the moving parts in your system. I can give you an example. If you read from DynamoDB or from S3, because it's in the region but outside of the VPC, it still goes through the NAT gateway, alternate firewall, whatever we talked about. So if you are paying for processing fees and you upload a file to S3, for example, or download a file from S3, you will pay for that, for the processing fees. You can use VPC endpoint to go around, but the thing is that if you know to evaluate, if you can evaluate the numbers in your environment, and it's above 5 terabytes, you should consider the alternatives. Below that, I would just recommend to use NAT gateway. Another easy solution for people that it's hard for them to evaluate that: run NAT gateway for 1 hour, check the billing the day after. Or run NAT gateway for 10 minutes, check the billing the day after.
Got it. And before we wrap up, is there any final comments from anyone? Anything we missed?
I would say it's going to be difficult to completely get rid of this extra charge, but at least this is a good time to reevaluate your architectures, both from a cost perspective and also from the security perspective. So I think it's a nice exercise to review your network configuration after this announcement.
When you say security perspective, you elaborate?
Yeah, as I said, one of the strategies is to try to expose as little as possible. That includes bastion hosts, jump boxes, and also your load balancers and NAT gateways or NAT instances if you used to use them, right? So the less you connect directly to the internet using the public IP address, the more secure you will be.
Got it. Well, thanks for spelling that out for simpletons like me. If there's no other final comments, then we can sign off. Going once, going twice. Sold. All right. Avi, Javier, thanks for joining us and sharing your knowledge about this upcoming price increase. So whoever's listening, you have a couple strategies to kind of mitigate the costs, minimize the impact, re-architect your application for cost and for security. We'll be sharing in the episode notes blog posts that you can read if you prefer that medium instead. And see you in the next episode. Thank you.
Bye.
Thank you. All right.
Cloud Masters is a DoiT multimedia production, hosted by Matan Bordo, a product marketing manager at DoiT, and Sam Clark, a technical account manager at DoiT. Our guests this week were Avi Keinan and Javier Carrera, both senior cloud architects at DoiT. Editing and production of Cloud Masters is handled by me, Crispin Stanback, multimedia content producer at DoiT. To hear more episodes of Cloud Masters and to learn more about how DoiT delivers the true promise of the cloud, visit doit.com for additional resources.